Good evening, everyone. Today we'll start the methods of preparation of alcohols. Okay, so mainly we will discuss methods of preparation of alcohol from. Let me write here summary. First from alkene. First from alkene. Then second one is from our carbonyl compounds. Okay, second one is from carbonyl compounds. Carbonyl compounds. Okay, and third one is from Grignard's reagent. From Grignard's reagents. So today in this class we will clearly prepare our alcohols, mainly aliphatic alcohols from alkene, then carbonyl compounds, mainly aldehyde, ketone, and carboxylic acid, and last one is from Grignard's reagent. Okay, so one by one, stepwise, with mechanism we will study deeply, and in a detailed analysis we will study our methods of preparation of alcohols. Okay, so first of all from alkene. So let me write the heading from alkene. From alkene. Okay, so if you will tell the methods of preparation of alkene, so alkene, we all know that alkene means there is a double bond between carbon atoms. The structure is like this, yes or no? So alkene is mainly of two types. Alkene is mainly what? How many? Two types. First one is symmetrical. First one is symmetrical, and second one is unsymmetrical. Clear? Second one is unsymmetrical. Symmetrical means contains around the double bond, means on both sides of double bond same number of carbon atoms is if present, then that is called as symmetrical alkene. If, let me take a simple example. This is CH2 double bond CH2. This is just symmetrical alkene, like this: CH3 CH double bond CH double single bond CH2 CH3. So this is an example of also symmetrical alkene. So this is ethene. This is ethene, and this is our what? But2ene. Clear? Okay. Like unsymmetrical alkene, what will be its unsymmetrical? CH3 CH double bond CH2. This is our propene. Propene. Yes or no? Very simple. Okay. This is our what? Propene. So this is unsymmetrical. You will clearly see on the both sides of double bond, here CH3CH, and here on the other side only CH2 is present. Both are different. That's why it is called as unsymmetrical alkene. So now we will prepare the alcohol from these alkenes. So if you add what? If you add water, let me write CH3CH double bond CH2. This is what? This is called as propene. When propene reacts with water, when water breaks, it forms what? H plus and OH minus ions. In presence of acid, it forms what? H plus and OH minus ions. This H come to what position? I will write the mechanism, but let me simply tell you first how the product will be obtained. Here pi bond will break, and according to Markovnikov rule, it will break, and H plus and OH minus, and the negative part will come to that carbon where less number of hydrogen attached. That means according to Markovnikov rule, the product will be like this: CH3 CHOH CH3. That means here OH come, OH minus will come, and here H plus will come. So we'll get the product that is called as what? Propan-2-ol. That is called as propan-2-ol. Clear? So this is our propan-2-ol, which follows what? Which follows our Markovnikov rule. Okay, very simple. We all know that what is Markovnikov rule. So Markovnikov rule says that when a unsymmetrical and terminal alkene react with any addendum, the negative part of it goes to that carbon where less number of hydrogen is attached, and the positive part goes to that carbon where more number of hydrogen is attached. Here 2 hydrogen is attached, here 1 hydrogen is attached, that means here less number, that's why negative part goes to this carbon side. Okay, and positive part goes to this carbon side. Okay, we'll get here what? Propan to oil. Very simple. Yes or no? Now let me write its mechanism. Okay, now let me write its mechanism. What is the mechanism of this reaction? So in step 1, what will happen? In step 1, protonation will take place. Protonation means what? In step 1, first of all, water reacts with H plus ions of acid and forms what? H3O plus ions. H3O plus ion means like this. Okay, this H3O plus ion will attack what? This H3O plus ion, here alkene is present. This alkene H3O plus is having positive charge. Okay, so here we can write this H3O plus as like this: OH, this is H, this is another H, plus charge and the lone pair of electron. Okay, so here the lone pair will attack here the lone to get stable, this lone pair will come to oxygen atom and this bond, pi bond or the what? This pi bond attack this hydrogen atom and take this hydrogen atom and form a carbocation. What? Form a carbocation. If carbocation is like this, CH3C, CH, double bond, C, sorry, single bond plus charge. Okay. So that means this lone pair, this bond pair form a bond, this bond form a this bond. That means the shortage of electron take place in this carbon atom. So this carbon carries a positive charge. Clear? With the removal of what? Water, because it attracts this bond pair towards itself and form water molecule. In step 2, what will happen? Step 2, this is protonation. This is called as what? Protonation. This is called as protonation. Clear? This is called as protonation. Clear? Now in step 2, what happens? In step 2, this carbocation, this is a carbocation. This is a carbocation. This carbocation again the water molecule will attack the carbocation. Water molecule, we all know that water molecule contains what? Water molecule contains oxygen atom. So this oxygen atom will attack, oxygen atom contain lone pair, this atom will attack the carbon atom and form this structure, this kind of structure. Clear? OH plus. Clear? Yes or no? Now deprotonation will take place. What is deprotonation? Removal of hydrogen will take place. Okay, removal of hydrogen. In the first step, H is added. In the last step, H will be removed. Step 3 says what? Step 3 will like this: C double bond and O. This is H, this is plus, this is H, and a lone pair will come because it contains lone pair, so it attracts the lone pair and remove and H plus ion. So H plus ion will be removed and we will get here what? We will get here a alcohol. And what? An alcohol. So deprotonation will take place and we will get here an alcohol. Okay, so this is our mechanism of what? Hydrolysis of alkene, and we will get here an alcohol. I hope it is clear to all of you. Clear? This reaction follows what? This reaction follows our Markovnikov rule. Now we will come to what? Hydroboration oxidation. Okay, the second methods of preparation is what? Hydroboration oxidation. Very simple. The second methods of preparation is hydroboration oxidation. Hydroboration oxidation reaction. So what is hydroboration oxidation reaction? Hydroboration oxidation reaction means what? Let me write here. So hydroboration oxidation means what? Okay, hydroboration oxidation means, first of all, here We will take an alkene CH3CH double bond CH2. Clear? Okay. This is also from alkene. These two prepare methods of preparation alcohol from alkene will take place. Okay. So this is also from alkene. This alkene react with what? Boron. What is the formula? Boron. Boron formula is BH3 whole 2. In presence of what? In presence of tetrahydrofuran. In presence of tetrahydrofuran, point number 1, and point 2 is what? Point 2 is hydrogen peroxide in presence of a base, strong base. We will get here what? A very simple product will be obtained. Okay, an H come from BH3 and here attached, that is, it will become CH3CH2 and a single bond, and OH come from this peroxide, hydrogen peroxide will come to this what? This will come to this carbon, and we will get here CH2OH. Okay, now we will clearly understand how this product will be obtained. This is our main product. Okay, this is our main product. Okay, so now let me tell you how this product will actually obtained. So let me write the mechanism one by one, stepwise. We'll clearly understand what is its mechanism. Clear? So its mechanism. Now I will write here mechanism. So why THF is used? First of all, BH3 boron. The structure of boron is like this: BH3. Okay. As boron does not satisfy the octet rule, it needs what? It needs electrons. So this is BH3. If boron undergoes reaction with alkene in presence of THFY, because tetrahydrofuran structure is like this. Okay, this is what is tetrahydrofuran? Tetrahydrofuran, I will write here tetrahydrofuran. What is furan? Furan structure is like this. This is our furan. Okay, this is called as furan. Okay, now if you just add 4 hydrogen atom, means if you reduce the structure, then you will get what? You will get tetrahydrofuran. This is called as tetrahydrofuran, shortly THF. Shortly called as what? THF. Very simple. Yes or no? This THF oxygen atom contains what? Lone pair of electron, and this lone pair of electron will attack to boron atom. Why this oxygen atom of tetrahydrofuran will attack this boron? Because boron needs electron pair. When this attack take place, boron cannot form its dimer. This is a dimer. Dimer means when two molecules mixed with each other, called as dimer. Okay, we need BH3 molecule, not B2H6. This is a B2H6 dimer. Okay, if dimer is formed, then this reaction will not take place. So to stop the formation of dimer, we have to use. So it is used for the it is used to stop the formation of dimer. It is used to stop the formation of dimer. Very simple. Okay. So if the dimer will be stopped, then BH3 molecule will be retained. Okay. So this BH3 molecule will exist if THF will attack the boron atom. So I hope it is clear to all of you. Okay. So now this this is step number 1. Step 2, what will happen? Step 2, CH3CH double bond CH2 will react with BH3. So BH3, it is stable now, because due to presence of THF will become stable. This here I will not write THF because THF is present, but the reaction will in this reaction we will not write that. Okay, so here boron is more electropositive because it is a metal. Boron is positive and it is what? Negative. Boron at okay. So boron is a metal, it must donate electron. That means here it must be negative. Okay, so what will happen? Okay, boron is more uh, negative. That's why it attracts the electron pair towards itself, and it is more electropositive. So H plus is needed. So negative part will go here. Anti-Markovnikov of this is what? This is positive and this is our negative. So BH2 negative, this will come to this and this will come to this position. So what will we get here? CH3, CH2, CH2BH2. This structure will be obtained because boron is more electronegative. Okay, boron is more electronegative, so it will get negative charge, and hydrogen is positive charge. The structure is like this. Okay, now again, this is the first CH3's propene structure. Then another propene is react with it. Another propene CH3 CH double bond CH2. This again, this boron attracts itself negative, and this is about positive. This total containing is positive, so boron negative attack will attack to more carbon containing, and positive anti-Markovnikov rule is applied. Okay, so what will happen here? The main product will be CH3 CH2 CH2, then B, then CH2 CH2 CH3, then another H is added, again another alkene is added, again another alkene, same propene CH3 CH2 is added, which same contains same positive charge, which contains same negative, and same positive negative will attack to this carbon atom, and positive will attack to this carbon atom according to anti-Markovnikov rule. Okay, so we will get here what? We will get here CH3 CH3 CH2 CH2 B whole 3. Okay, tripropyl boron. This is called as tripropyl boron. Clear? So this is called as tripropyl boron. We will get a structure like this. Okay. So now in the next step, what will happen? In the next step, we will get to our next step. We'll go to our next step. So what will happen? Let me write here. In the next step, this boron, this trimethyl boron, CH3 CH3 CH2, so CH3 CH2 CH2 CH whole 3 B. I will write here this as R3B, trialkyl boron. Okay, this trialkyl boron will react with what? H3 H2O2. Next step. Okay, so in step 3, what will happen? Let me write first of all this H2O2 means H2O2 react with OH minus ions. What will happen when it react with OH minus ion? So when it react with OH minus ion, this H2O2 when react, this H2O2 can be written as OH. Okay, so here it attracts H plus and OH minus, so we will get here water and OOH. Okay, OOH. this lone pair will be attracted by oxygen atom, so it will get negative charge. Okay, so this OOH minus will attack this R3B. Okay, in the next step 3, this R3B, as boron is a metal, so this OOH minus will attack this boron. Okay, when this O minus will attack this boron, this structure is like this: R3B OOH, but boron acquires what? Boron acquires negative charge, but boron is a metal. So what will happen? As boron is a metal, boron shows inductive high plus I inductive effect. Okay, it will repel the electron because it has high plus I effect. Okay, so it will repel the electron. What will happen? This bond will break. How this bond will break? As this is O minus and this is positive, because it will repel the electron, so this is kind of positive charge, and this is here what? kind of negative charge. So an OH minus will be removed. So OH minus will be removed, and an R come to this side. Come to this side, we will get here R3, R2B, R2BOR. We'll get a product like this, R2BOR. Again in this R2BOR, again another OH, how many OH are actually obtained? So 3H2O2 will be taken here, so 3 OH will be taken. Okay, if I will take 3, then 3 OHL, then 3 number of water molecules, so another OOH minus will attack like this. This will attack what? Boron again, and the structure will be like this, B what? OOH. Okay, then this structure will be what? Broken, must be broken. This is having positive charge, this is having negative charge. Again OH minus will be removed, OH minus will be removed. Then what will happen? An R group come to this side. Okay, an R group come to this side. So we will get here RBOR with OR. Again another OOH minus will attack to boron. Again same structure, RBOOH with positive, and this is our negative, and OR, and another OR will be obtained. Okay, so this again, this negative charge will be removed, minus OH, and to get stable this R will go to that direction, and we will get here what? B, what? We will get here B, BOR, what? BOR, then another BOR. Simple? Yes or no? Very simple. Now at last position what will happen? At last position as water molecules are there, how many water? 3 water molecules are obtained here. So as you clearly see here, 3 water molecules were obtained. So these water molecules will attack like this, 1 HOH, 1 water, 3 HOH means 3 OH minus H plus, 3 OH minus. So this bond will break, and H plus come to this side, H plus come to this side, H plus come to this side, and 3 OH come to middle boron, and we will get here product what? R3ROH plus BOH whole 3, boron trihydroxide. Okay, by putting the R value here, that is propyl, we will get here CH3, 3 numbers of CH3, CH2, CH2OH. That means propanol will be obtained. So main product is our propanol. I hope it is clear to all of you. This is our mechanism of hydroporation and oxidation. I hope it is clear to all of you. Okay, now we will understand now we will understand the different now the second method of separation is from what? From carbonyl compounds. Okay, the second one is from carbonyl compounds. What is carbonyl compounds? From carbonyl compounds. What are carbonyl compounds? Carbonyl compounds means what? They must, the carbonyl compounds means aldehydes, ketones, carboxylic acids. Okay, so these are the carbon, because they contain a common group that is called as C double bond O, which is also called as what? Carbonyl group. Okay, so now let me write here an aldehyde, R C double bond O H. This is an aldehyde group. Clear? Okay, now let me write here okay, now from aldehyde, 2A from aldehyde, okay, I will write all the aldehyde, ketones and carbonic acid. Okay, let me write here aldehyde, then let me write here ketone, R C double bond O R. This is a ketone. Okay, now if I will write here a carboxylic acid, R C double bond O R OH. This is a carboxylic acid example. Okay, so in all these reaction we will need here some reducing agent, because we have to do our reduction, so H2 is needed. Addition of hydrogen is must, because in the case of reduction hydrogen must be added. So in case of reduction we must use some reducing agents. We can use what? Palladium, NaBH4, sodium borohydride. We can use LiAlH4, lithium aluminum tetrahydride, etc. These catalysts can be used for the reduction. If I will reduce this aldehyde, then what will happen? This bond will break and 2H, okay, this pi, only pi bond will break and 2H is added. One this sigma bond is not broken, this pi bond will be broken and 1H is added to carbon and 1H is added to oxygen. So what will happen? RCH2OH, that is alcohol, that is our alcohol. Clear? Then if you reduce this structure, then what will happen? Another pi bond is broken, C double bond, 1 sigma, another pi, so pi will be broken and what 2H will be added to 1H carbon, 1 to carbon, another to oxygen. What will happen? R C single bond OH, then CHOH, RCHOH. This is alcohol also, but this is a secondary alcohol. This is our secondary, this is our 1 degree primary. Okay, then this RCOH, this is a carboxylic acid. Okay, this is a carboxylic acid. So what will happen? This here we need more amount of hydrogen, because 2 sigma bonds and pi bonds will be broken here. Okay, so RCH2OH, there is also formation of primary alcohol in this compound with the removal of water molecule. Okay, so I hope it is clear to all of you. So these are the production of alcohol from carbonyl compounds. Is very simple and very easy. Now our last methods of preparation is from Grignard's reagent, from Grignard's reagent. Okay, this is our last methods of preparation of alcohols. So what is Grignard's reagent and how can we prepare alcohol from Grignard's reagent? So it's very simple. So first of all we can take any carbonyl group. Carbonyl means it must contain C double bond O. Okay, so this carbonyl group must added. Let me take aldehyde first. Let me take, this is an aldehyde group. Let me take any aldehyde, RCHO. If I will put here CH3, then we will get here what? CH3CHO, that means acetaldehyde. This, let me take acetaldehyde, CH3CHO. This aldehyde, okay, when acetaldehyde react with RMGX or CH3MgBr, this is methyl magnesium bromide. This is called as methyl. This is our acetaldehyde. This is our acetaldehyde. Okay, these are methyl magnesium bromide. Methyl magnesium bromide. This is a metal, so it will give positive charge, it will give electrons, so it becomes and acquires positive charge. And here, whereas it is carbonyl group, acquires oxygen is negative and carbon is having positive charge. So CH3 will attack what to carbon and magnesium will attack to oxygen atom. Will be get here what? Will be getting here CH3H, then C, then what? Then OMgBr, and this is our CS3. So what will happen next in the next step? In the next step we will adding here water. In the next step we will be adding here water. Water, this is negative, this is positive. Water will break and forms what? Water will break and form H plus and OH minus. Clear? So what will be getting here? What will be getting here? We'll be getting here CH3, CH, then OH, then CH3. Okay, this is called as propan-2-ol. This is called as propan-2-ol. I think it is getting clear. So I hope you all clearly understand what I tell you here. This is our preparation of alcohol. This is a what? Propan-2-ol. This is a secondary alcohol. This is a secondary alcohol. So I hope it is clear to all of you. In this class we have clearly prepared alcohols from what? From first alkenes, then we will use our what? Hydroboration oxidation reaction, then from carbonyl compounds aldehyde ketone carboxylic acid, then lastly from Grignard's reagent. So I hope it is clear to all of you. It's very simple. If you have any doubt, then you can call me. Okay, you can contact me. Okay, and you can comment in my comment box in my YouTube channel. Thank you everyone.